Hello everyone, let's look at this integration by parts problem. Today we have the function x times e to the negative 2x, and so this is a product of two functions, and because integration by parts is for reversing the product rule when you're doing the differentiation, so this is a good problem to try. And so let's start. First, before we actually start the problem, we are going to recall the integration by parts formula so that we can just follow the formula from here. And so let me write it down here. We have the integral of u dv, and then that's equal to uv minus the integral of v du. And so we are going to treat our integral here, this problem here, as the integral on the left-hand side of the formula. And we are going to rewrite this in this form on the right-hand side, uv minus the integral of v du. And then we are hoping that instead of integrating the integral of u dv, we're hoping that we can actually integrate the integral of v du. So that's the idea for the integration by parts. And so let's start and just avoid this from getting in the way. So let me move it away from to a side. So now we can start the problem. So we are going to set up the table with the uv and then the du dv in there. So you probably have seen this if you have learned integration by part in your classroom. So let's set that up. So we have u here and then du, and then you are going to have v here and then dv. Now, what are we going to do? We are going to choose which one is u and which one is dv. And so basically we are trying to fill in this blank right here and then also this blank. And the strategy of choosing it really often it will depend on the experience, but online you can actually find that a lot of people are saying that we can actually follow a certain order. So you can search for it. The order that it's liate. I will talk about this in the future, but right now let me just talk about how we usually decide which one is u and which one is dv. Okay, so let's look at the u first, because that's the integrand that you have here, right? So we actually don't have that many choices because we only have two functions. So one choice is that we are going to let u be x. The other choice is that we are going to let u be e to the negative 2x. So that means dv would be the other function. Now, if we are going to let u be x, and so we put the x here, and then dv would be what? dv would be e to the negative 2x. So we have e to the negative 2x, and actually you are going to also put the differential here, the dx, right next to the dv. Okay, so now what we need to do is to find du, which is the derivative of the u, and then we also need to find v, which is the antiderivative of e to the negative 2x dx. And the question is, should we do it this way or should we do it the other way? So just to compare, I'm going to set up another table. And then see what actually would be going on. So the other way to choose our u is to, well, you only have one choice left, which is e to the negative 2x. So we can put that in here, which is e to the negative 2x. And then the dv would be what? The dv would now be x. So we put the x here and then also the dx. Okay, so now we do both tables and see which one will give us the better result. So when you differentiate the x, you're going to get 1, right? So you're going to get 1 and then times dx, right? So 1 dx. And usually if you're just getting a 1, you don't even need to write it. So we can simply just put a dx here. What about the v? The v would be the antiderivative of e to the negative 2x. So if you integrate this function here, you're going to get e to the negative 2x, but don't forget the chain rule. And so remember, if you're differentiating the exponential function here, e to the negative 2x, you are going to get an extra factor of negative 2. To cancel out that negative 2, you need to put a negative 1/2 in the front. So negative 1/2. Okay, so that's That's what the table is. Now, if you put that down, if you follow the formula and then put down the right hand side, it's going to look like this. We have u times v, right? So let's do this. We have u times this v here, so let's put that. We have x and then times, what is that? That's -1/2 e to the -2x. So -1/2 e to the -2x. And then minus. And then the integral of v du. So the integral of just this one, well, there was a du too, but then the du will just give you the dx. There was no extra stuff right here. So you are going to get the integral of the -1/2. Now, this table setup is getting in the way, so let me move them a little bit too. So just move them here. Okay, so we have the integral of v, right? So just copy the v here, e to the -2x. And then the du. The du is the dx, so we put the dx here. Okay, so now the question is, can we integrate this here? Is it possible to integrate? Yes, we can. So this setup works. So this choice of the u, where u is x, and the choice of dv, where dv is e to the -2x dx, it works. So this choice works, though. That means we can finish the problem. Now let's look at the other option here. So we let u be e to the -2x, and then we let dv be x. Differentiating this function here, e to the -2x, we are going to get -2 e to the -2x dx. And when you integrate x here, you are going to get 1/2 x squared. And so now when we try to write down the right hand side of the integration by parts formula, you can see that the v, right, the v, and then the du, you are going to get 1/2 x squared times -2 e to the -2x. The 2 and the 1/2 can be canceled, but then you still have the x squared and then e to the -2x. Let me write it down for you, then you can see. So I'm just going to write down the right hand side and see what's going on. We have e to the -2x, that's u, and then the v is 1/2 x squared, okay? And then now minus the integral of v, which is 1/2 x squared, and then the du, which is -2 e to the -2x, and then dx. Yeah, so if I am to label them, that's u, that's v, this one is v, and then that whole thing is u. Oh, actually, that's du. Okay, so if you look at this one, after you clean up this expression, you are going to get positive. I'm getting positive because I have a minus sign here and another minus sign here. The 1/2 and the 2 will get canceled, so you are just going to get the integral of x squared e to the -2x dx. Now the question is, can we integrate this one directly? We cannot, right? Because that's still a product. And actually, you can see that the function looks worse. So this choice of the u and the dv does not work. So we actually need to go back to the original choice. Yeah, so we actually cannot do it this way. That means if you see a product of the x here and then e to the -2x here, you have to use you have to set u to be x, and then you have to set dv to be the exponential function. Okay, so now let's erase all this stuff because we don't need it anymore. Okay, so as you can see, sometimes only one choice will work, the other choice may not work so well. And so that's the problem. And we'll talk more about the strategy of choosing the u and then choosing the dv. But right now, let's just finish the problem, and then we'll show you the tablet method which will be more convenient for the calculation. And then I will talk about more strategies about choosing u and the dv. Okay, so we are going to continue with the problem here. We just clean up the first term here. So we are going to get negative 1/2. And then I move the x here, and then you get e to the negative 2x. Okay, so next step is that we have a minus sign here, and a minus sign here. You can also pull the 1/2 outside the integral. So you are going to get positive 1/2 integral of e to the negative 2x and then dx. So you can see that that's really just a simple function that we can integrate. We actually did that integration here when we find the v from the dv. So we can do it again. We can find the antiderivative e to the negative 2x, and then we can find the answer. So we are going to have negative 1/2 x e to the negative 2x, and then plus 1/2. This 1/2 is from here. And then now we integrate this e to the negative 2x. So we have e to the negative 2x. I'm leaving some space here because I need to put that negative 1/2 in front of the e to the negative 2x to reverse the simple chain rule. So we are going to get negative 1/2 here. And then now just one more step to clean up the expression. So our final answer would be negative 1/2 x e to the negative 2x. And then minus 1/4. And then e to the negative 2x. And then plus c. And so we are finished with the problem. Thank you for watching.